Okay, good afternoon, everyone. My name is Joseph Cevetello. I'm the CIO at Santa Monica, and I'm joined by four really smart and talented gentlemen, and I'm going to have them introduce themselves, and then we're going to get into our topic. Fire away.
I'll start.
Yep.
Name's Jared Goodner, co-founder and chief technology officer of Akido Labs. Akido's a full stack provider, meaning we're a technology company. We're also the providers themselves, and we care for populations generally considered vulnerable and suffering from chronic illness. Background is largely software engineering, stint in academia.
Hi, hello everyone. Yeah, I'm Chaoyang. Yeah, currently I'm the co-founder and CTO at FedML.ai. My background is like federated learning, machine learning, and blockchain. Before starting this company, I graduated from USC, also in LA, and also previously I worked in the internet industry for almost 7 years. Yeah, that's my background.
Hello everyone, my name is Dimitris. I am currently a PhD candidate at USC, focused on federated learning, and I'm also co-founder CTO of Never AI, and we provide solutions, federated learning solutions in biomedical and healthcare organizations. Thank you.
Great. And Karan, can you introduce yourself?
Yes. Hey, I'm Karan Singhal. I'm a researcher at Google Research. I help lead a couple teams at Google are working on areas like federated learning, representation learning, medical AI, and so on. I've been at Google for 3 years, and prior to that, I graduated from Stanford.
Great, thank you. Okay, so not wanting to make any assumptions about what we mean by federated learning, I thought I would read off our working definition of it for this discussion. Federated learning is an ecosystem of computational approaches and techniques that enable geographically distributed entities to form secure and private coalitions and jointly analyze their siloed data. Data never leaves the original source, and each entity only shares its locally trained AI ML model with the outside world. Through this collaborative learning method, entities can extract knowledge that is statistically more powerful, less biased, and more accurate when compared to the learning conducted independently. At its core, federated learning uses distributed machine and deep learning methods, as well as privacy-enhancing technologies to empower learning in real-world settings. So that's our very specific definition of federated learning. So knowing that, I think we want to start off talking about use cases. I got to get to my notes. So let's start with believing that that definition is totally valid and fits in with this discussion. Let's talk about some of the benefits of federated learning. I mean, why do this? Why not just hang out on your own and keep your learning and your models to yourself? What are the benefits? And maybe Jared, you can start off by telling us about some of your experience in healthcare.
Yeah, sure. So if we're to talk about federated learning, maybe talk about those two words. The learning being, what really creates the value for our end users. And I think, there's several panels today that talk about the learning aspect and the benefits of being able to use statistical methods in healthcare. But to simplify it, the learning allows us to dramatically scale up the volume with which we can do these complex statistical analyses to do things like perform radiological assessments that would otherwise require humans, or identify early markers of a progressing illness. On the federated part of federated learning, so the federation there, like Joseph said, refers to the federation of data silos, essentially. And so the primary benefit, in my opinion, really is that it allows us to address a lot of the concerns that have historically prevented technologists and entrepreneurs from implementing sophisticated data technologies in really sensitive environments. It allows us to break down silos without compromising on things like data security and regulatory compliance and corporate politics and business models, particularly healthcare business models. Just an example for each of those. So on the regulatory compliance piece, say we are looking to implement a new technology that leverages statistical learning. We're going to need approval from the compliance department in a hospital, for example, right? Let's use that hospital framework. So in communications with that compliance department, they're going to be concerned about HIPAA. They're going to be concerned about privacy. And so we can say that that data that historically you would be transporting to somebody else and literally sharing with somebody else is no longer actually shared. And that goes a really long way towards assuaging the concerns of that compliance department to say, hey, this technology doesn't require sharing like those other technologies do, and essentially accelerates that thumbs up, right? Moving out of compliance, let's keep using that hospital metaphor, to like an IT department. IT departments are very concerned about security, legitimately. And so the conversation is very similar, right? We're not actually sharing the data. We're not transporting it to another location. This goes a long way towards assuaging the concerns that the IT department is going to have around things like data access and data security. The corporate politics thing I found is quite interesting. So in large organizations, you know, for better or for worse, there is politics that develops around data ownership, right? To very simply, if I own a data set within an organization, if you want access to it, I can say, what are you going to give me in return? And just natively, that tends to happen. You know, I think we'd like for that to stop, but as technologists, we can't stop it ourselves. And so the federated approach allows us to communicate with those stakeholders that we have to give us the thumbs up, that, hey, that moat that you've built to maintain your power and your leverage, we actually don't have to cross it. You know, that data stays within your moat, and you can be sure that you're keeping the power that you've generated over the past years. The last piece is business model, right? So data sharing in healthcare can be quite sensitive from a business approach, so, or from a business model standpoint. So again, to use hospitals, you know, between hospital insurance company, negotiations there that really determine pricing for hospital services and how much money hospitals make. And so that negotiation process is quite sensitive. The dynamics of that negotiation can shift when the insurance company knows too much about the hospital's activities. And so assuaging the concerns of those executives to say, it's much less likely that that data is going to end up in the hands of somebody over that insurance company goes a long way towards making sure that that data is usable with these new statistical learning methods.
Thank you, Jared. And Karan, I think you wanted to talk about, from your perspective, talking about across devices.
Yeah, absolutely. So the setting often studied at Google is the setting of cross-device federated learning, where instead of different hospital silos collaborating to learn something from siloed data, the use case is different users have different amounts of data on their devices, and we want to learn a shared model from all of that data in a way that kind of benefits the users. And so that in that setting also, there's also this additional benefit of federated learning enabling us to train models that we otherwise wouldn't be able to train, which is a lot of what Jared talked about. So a lot of this data would not otherwise be available. So for example, the mobile keyboard app on iPhones or Androids, that data used to train those keyboards would not otherwise be available without federated learning. Another thing I wanted to mention that's specifically pretty important in this cross-device use case is the problem of kind of robustness to different distributions. So when you're dealing with different users who have different ways of, for example, typing or different skin conditions that they might have, you might run into an issue where because of that difference in distribution, I think Vivek also talked about this in the keynote, models might not perform super well when tested on that distribution shift. And so what federated learning enables you to do is it enables you to train on a wide variety of devices that might not otherwise be able to share and participate in training.
Thank you. So let's dive a little bit deeper into use cases. Karan, can you tell us about some more examples of use cases on various devices, kind of diving down a little bit deeper into it?
Absolutely, yeah. So federated learning was originally started at Google around kind of the concept of cross-device federated learning, and there the use case was the original use case that kind of motivated it all was the mobile keyboard use case, which is being pursued by both Google and Apple, where the goal is to be able to learn better predictions for what you are typing on your mobile keyboard. So that autocomplete feature on your mobile keyboard is a simple example. And for that use case, you want to be able to train using the knowledge of what people have typed in the past, but you also want to make sure that you're preserving privacy and you're not sharing that data with Google because it's highly sensitive data. And so that mobile keyboard use case has been the source of a lot of individual applications. Another one I want to highlight more in the healthcare domain that Google is also interested in is around this Dermassist app that Vivek mentioned during his keynote. And so for this app, as a reminder, it lets you take a picture of your skin and classifies it into 288 different skin conditions at accuracy similar to that of a dermatologist. And there again, it seems pretty valuable potentially to be able to do federated learning, to be able to learn from different kinds of data. And so we have some earlier work showing that something like that is viable.
Great, thanks. Dimitris, I think you have an interesting use case that you can tell us about.
Yeah, so far we're working on neuroscience, and we extended it to a federated neuroscience concept. As an example, for instance, you have brain MRI scans and you want to analyze them in order to detect whether a patient has an Alzheimer's disease or not. So there are different processes that you can, leveraging deep learning or machine learning models to detect whether a patient from the MRI scan can have progression in Alzheimer's disease and whether he's whether he has other neurological diseases. And another example is, for instance, is the brain age gap estimation, which is a critical biomarker when you want to detect whether a subject or again a patient has any neurological disease. These are usually data that are regionally stored. Let's say hospitals may have them, isolate them, and so they create their own silos. And in that use case, you usually, for instance, MRI scan. Some hospitals, for instance, may have only 100 records. Other hospitals may have only 20 records. So you see that there's a scarcity in terms of data or availability in terms of MRI scans. And this is where federated learning comes into the place, because you can leverage the federated learning concept or the paradigm to jointly analyze this data so that you can create a more robust and more powerful statistical model in order to detect this kind of diseases. And I see that, for instance, and also another example in this particular domain, the neuroscience, you might have different scanners also. So that creates also different data distribution shifts, as Karan said earlier. In that case, you might have different population biases. So you want to leverage this, so you want to analyze this data in a way that you can avoid having this particular bias in your machine learning models. And this is usually done by having more available data. And again, this is where federated learning can help you, because you can use it to analyze data without migrating, of course, from the original source. So for instance, if you have a hospital in Europe, another one in, for instance, in Netherlands, one in New York, another one in LA, you can jointly analyze this data in order to train more robust models. And I think this is where federated learning really shines in that concept, because you can provide better detection and prediction for particular diseases, and that was just a use case. But imagine where you can leverage it in order to have more generalized solutions in that domain.
Great, thank you. And Chaoyang, I think you have a couple of use cases you can share with us, right?
Yeah, I think you already talked about the healthcare and like the smartphone cross-device setting. So actually in our company at FedML, we also do similar applications like healthcare and even cross-device like Android platform. We recently released it as open source. So if you can try, maybe you can use it for healthcare. I think that's very interesting platform. But I think I can add two scenarios that we tried recently that try to enlarge the scope of federated learning. So in our company, we view federated learning is a way that you can train a model in decentralized data. So it's not necessary to be cross smartphones and cross organizations. So we hope we can enlarge the concept into blockchain world, especially in Web3. because in Web3 we view data is decentralized. For example, the on-chain data, although each blockchain each node you can see the on-chain data, right? Each node you can see it, but in practice you also need to process many off-chain data. So what if there is a scenario you want to process both on-chain and off-chain data? So in this case we call it data economics, meaning that people can trade the data and to get some tokens. So this token is kind of reward to appreciate your contribution for federated learning. For example, you want to train a medical image models, right? So everybody can contribute some, for example, X-ray image and to this model, but you don't need to move the data to the cloud to train the model. So maybe you just put your model still in your laptop, and then we have federated learning edge nodes on your laptop, then we can do a decentralized training. And this training process will be involved to, for example, the smart contract. So you submit your contribution, the smart contract will try to proof of your contribution and then rewards, give you some tokens. So I think this is also an interesting platform and application that we are trying to release maybe early next year. Yeah, so we raised our second round of fundraising to finish this platform. Yeah, and this is the Web3 world kinds of federated learning. And also we have find other interesting scenario like smart manufacturing and new retail. For example, you have you want to train surveillance or smoke detection in this room, but there's a lot of privacy here because they will capture our face here, right? So we don't hope to this data be decentralized to the cloud. So what if we can train, have an edge server around here, for example, the edge server there, and then we can train directly on the edge server so that it can protect the privacy. I think this kind of decentralized training will happen a lot in the future, especially in the cloud. We cannot hold all the big data, right? What happens if the cloud storage cannot hold all the data? So I think federated learning is a must in the future for data platform and AI. Yeah, so I think these are two new perspectives from our company. Hoping they have to understand federated learning in a larger concept. Yeah, thank you.
Great, thank you. Okay, so this seems like a good place to maybe pause. We've talked about the benefits of federated learning, some use cases about federated learning. I'm wondering if there's any questions based upon what we've already discussed. We have more things we're going to talk about, but just wanted to give the audience a chance to ask any questions, or if there's anyone online that wants to ask a question. Sure, go ahead.
I was wondering if the training is completely federated and distributed among the edge users, then what's the revenue model look like for somebody? Like, if they don't train large populations, then what kind of IP do they have? And how do they monetize that?
You want to take that? Jared, is that good for you?
Not my world really. I traffic in healthcare these days, but that's a really interesting question. It sounds like if I were to repeat your question, tell me if this is what you were asking. If the model learning building happens on the edge device, then does that IP actually belong to the organization that installed that model on that device? Or does it somehow belong to the individual who owns the device? Is that right?
Yeah, like is it like crypto equivalent would be like, is it like a DAO, or how is it profitable for the company if they rely on the users to kind of do that?
I can answer from the standpoint of from like my background. We worked on a project with the FDA pre-COVID that was interested in identifying flu cases and cases that presented as something else, but were actually flu within hospitals across the country at a large scale. And so this is a case where learning wasn't as much of an issue, but the federation was really important because really difficult to get all these hospitals to agree to share data with each other and with the federal government that quickly. This needs to happen very quickly. And so the IP in this case belonged to the FDA, because very clearly the FDA, along with us, had developed the technology that we then installed in the hospital. And while it was the hospital's data, we needed some legal documentation to access that data and do something with it. The IP of the technology was not that hospital's IP. And so that's just one example that comes to mind of a situation where you're doing a lot of work on the edge, but the actual IP belongs to the organization who created the tech. And you guys have any other thoughts?
Yeah, in terms of business model and IP, I think the way you see in the healthcare setting, that's more like global training, right? So the global server gets the model, and then the IP belongs to the organization who want to trade the model. And for the edge users, I don't think they have IP in this case. Right. But in our company, as I just mentioned, the Web3 based federated learning, I think that's a concept in academia. We call it personalized federated learning, meaning that each person will have a personalized model. And so in this case, the model trained will be directly used by the end user, it's not by the global organization. So in this case, we will use tokenomics, like get some reward for the users. And so in this case, I think the IP belongs to the community, because in Web3 world, AI for the by the community and for the community. So I don't think there's a specific person can have the IP of the personalized model for the built by the entire community, although you get some rewards. And there's no essential globalization to control the model. So that's the beauty of decentralization in blockchain world, right? So I think these are two kinds of IP that, in my understanding, in terms of business model, I think if you look at the current federated learning startups, what in my understanding, that most of them are building open source libraries. For example, our company also built the open source library, but simultaneously we also have B2B business model. For example, we serve the healthcare settings like the hospital or the IT company for medical AI. For example, your company, I guess, a similar business model that is B2B. So in this case, it's kind of subscription or license fee. But simultaneously, we have another business model that is subscription. For example, we have a platform, we call it Open Federated Learning Platform. So in this platform, every developers can directly register account there. And maybe you just pay a monthly fee, like maybe $10 per month. So by this way, you can use all the tools in the platform. So I think that we call this as a B2D, that's business to developer. So these are two kinds of traditional business model. But in the blockchain world, we are trying to build a community that is based on, so the business model is tokenomics, meaning that you have to chase a token price to engage more users to use the platform, to trade the data, trade the model, and to collaboratively build the AI system. Yeah, so these are three kinds of model, as far as I know.
Yeah. Awesome. Great question.
Any further questions before we move on to our other topics? Think back there.
How easy is it to remove bad data from the combined model? Like if one actor is either intentionally or unintentionally training incorrectly, and then you've got this big federated model from dozens or hundreds of sources, and you discover at some point that you need to take their data out and remerge it, you don't have to retrain, right? You're just merging models at that point, and that would be quick, or is that a disaster?
Yeah, who wants to take that?
So there are different algorithms when you join this particular model from different actors. You can have malicious actors that can act as outliers in that sense. So maybe even if there are different works that show that, for 100 clients or 1,000 clients, there are different robustness that you can guarantee when you merge these models. But there are techniques that are more sophisticated. So you need to count for these outlying parameters, let's say, when these actors are sending the models to the centralized entity that combines all these models. So there are different trade-offs, but still you can account for malicious actors up to a particular percentage. So for instance, up to 30 or 40%, which is actually extreme, you can really account it, and you can have not the perfect model, but at least some reasonable model that you can use it to perform some inference eventually. But if you go above 50% or 60%, so basically the entire federation is corrupted, then definitely you cannot do anything more than that. But there are techniques where you can account for outlier detection, and you can provide some alleviation, or you can alleviate these particular malicious actors that they want to hurt your federation. So basically, they want to backdoor the federated learning process. So there are ways to merge that. We can't go into the technical details, but I think it's.
Anyone else care to? Karan, I don't want to forget about you. You're on our screen in back of us. So did you have anything you wanted to share on this one?
Absolutely, yeah. I think Dimitris did a great job of talking about the model poisoning attacks. And I think there are solutions to those kinds of model poisoning attacks. And a lot of them are kind of worst case, like 30, 40%, like Dimitris said. And so that seems a little bit comforting. I think one way this question, I think this is a great question, because I think this question has become more relevant recently with kind of big models, foundation models that are trained on a lot of data in the web, for example. And these models have effectively memorized or learned a bunch of data that has not been carefully vetted. In some cases, some of this data might be bad. And this question of how do we retrain, or should we retrain, or do we emit this data from our pre-training, I think this will become more and more relevant. But in federated learning, there are ways to kind of avoid kind of training on it in the first place, as Dimitris mentioned.
Thank you. All right, why don't we move on to some of the challenges, roadblocks, and let's contextualize it in healthcare. So Jared, what are some of the roadblocks and challenges that you've experienced in applying this in healthcare?
Sure. Well, maybe I could talk about some of the less technical barriers, and you guys can dive into some of the technical stuff. So one thing is, I think a lot of the issues that we see in any kind of data work in large organizations, especially in sensitive environments, is going to apply here, to some extent anyway. So the issue of data quality is a big one in healthcare. We have medical records that, in the simplest case, use different units for the same kinds of measurements. We capture a tremendous amount of unstructured data and free text notes. And so quality can not only vary tremendously, but also can be quite difficult to clean those data sets. And so that's a problem that we see in a lot of places, federated or not. Yeah, that's just a general issue, and it still exists here. Another one is that's kind of interesting that we've run into is that because it allows us to approach data sets that otherwise are very difficult to gain access to, for good reason. The work can sometimes be kind of pioneering, right? So in those cases, sometimes there's no playbook for how the organization should make decisions around providing access to that data. I think that we saw similar issues working with, homelessness data in Santa Monica. And so when there is no playbook for how to properly provision access and what it means to utilize that data in a model, it can be difficult for those organizations to make decisions. And so that's one of those blockers that may not be so obvious, but it's certainly a thing.
Yeah, and I was just going to say so we were fortunate enough to work with Akido Labs, which is where Jared was and is. And yeah, we were doing something that had never been done before in a city, which was combining homeless data and then serving it up in real time to first responders. And probably the biggest lift was just figuring out how do we combine three of the most sensitive data stores in the entire city: police data, which is criminal justice data, fire data, which is HIPAA data, and then homeless management information systems, which is a whole different county system. How do you free up access to people who aren't necessarily part of any one of those departments. It was a huge lift, and these guys stuck with us, and they figured it out technically really fast. It took us a long time to figure it out,
Legally.
yeah.
Legally, it's quite complicated.
Yeah, it's
You know,
very
you've got
complicated.
HIPAA that covers a lot of the healthcare data, but for a lot of the data that's not within that HIPAA domain, it's kind of, there's no playbook. Yeah.
Great. Dimitris, I think you had something you wanted to add, right?
Yeah, so I think there are three different arms that, they put a barrier on actually applying federated learning. First of all, you need to convince the healthcare organizations, the biomedical organizations, that this is something beneficial for them, for their patients, or for the entire organization. So you need to show the added value of joining federations and why it's critical for them, and eventually, how it can help them in the decision making and maybe add some more revenue in their entire pipeline. But the second critical thing is that, yes, let's say that you convince a hospital to join the federation. Does it have the necessary infrastructure to actually help during the federated learning training? So does it have the servers that you need in order to train an AI deep learning model, which actually is pretty expensive models, which you cannot use a regular laptop to perform this particular training. Yes, when we go to the cross device with our different mobile devices, you're doing personalization, which is a different concept. But when you actually training from scratch deep learning models, that's pretty expensive computationally. And the third part is what Jared said earlier, which I will frame it better with the data harmonization, is when you have, you have 10 hospitals that perform that, they collaborate to create a federation. Do they have the data in the proper format in order to train the machine learning models? That's also something very hard to solve on the fly. And it takes a lot of offline procedures in order to alleviate this problem and harmonize this data and make them more structural and use them during the training pipeline of the learning models. And definitely, finally, is whether I think it goes back to infrastructure. Is whether the hospitals have the necessary capacity, not only in terms of infrastructure but also in terms of the IT department, that you can communicate properly, and then in order to establish kind of federations in this particular training. So there are different problems that arise at different barriers, let's say, in order to make federated learning more applicable in the wild.
And Chaoyang, I think you have another blocker, right? A very different one.
Yeah, maybe I think we already talked about the policy and some infrastructure. Maybe I can add some the bottlenecks we met in technical side and eventually in the production-wise. Recently, we serve for a medical AI device company, so they already have some devices installed in the hospital across. I think there are about 5 countries, including Japan, US, European, and China, for example. So what if they want to train a model collaboratively across so many hospitals? So the case is, in this case, we met 2 key problems. The first one is that even you have multiple hospitals want to collaborate, but the number of samples is still very limited, because each hospital may only have some positive of this disease. Maybe there are only 10 positive disease in this year. But the negative label is very, maybe a lot, right? So we call this problem as small data. So how you can train a federated learning model on small scale data. So in total, maybe there are only a few hundreds, but in ImageNet, if you want to train, for example, ResNet model, you normally need a million level image. But in this case, you only have a few hundreds of samples, and especially the positive and negative sample, the ratio is very biased. So then how you can solve this small data problem? And another problem is that in this case, we hope the doctors can help us to label the image there. But the problem is that they normally doesn't take the job because they're very busy to take care of the patient, to talk with the patients. They don't have convenient tools to help you to label the image, right? So this problem, we call it that label deficiency. So in academia, especially in this year's workshop, I think it's triple AI this year. So we published a paper talking about how you can train a federated learning model in self-supervised learning. So this is a very hot topic in academia, but it's still, we tried, it's still far from the production. Even you try semi-supervised learning, still you cannot make the accuracy very perfect. So I think these to bottlenecks for real world settings, that you don't have enough labels, you don't have enough samples, how you can solve the problem. Yeah.
Great, thank you. Okay, this seems like a good place to pause as far as blockers and challenges. Any questions from the audience? Got one right over there.
So you talked about a couple of the roadblocks in the federated learning. How about like the model updates or the shifts in the data set? How often do you have to calibrate your model or make sure that some of the changes in the EHR side for a hospital happened and this is why the model is failing? How do you calibrate or make sure that the model is updated in those different sources?
Yeah, so that goes back to model refinement. So you can think of it in academia, there are more in data warehousing. How often do you update your data warehouse, your data lake, right? That's the same concept in the model. How often do you update the model? You can, of course, have some triggers depending on when you have new data coming in from the participating hospitals that train the model, so you can refine the model in that sense. But also you need to account for how expensive it is to retrain the model, because it's not an easy procedure. So there is no, silver rule here that you can use something specific, every week or every day. So I think it's going to be a little bit more, needs a little bit more research on that front. Not a straightforward answer, but yeah, it's up to the stakeholders of the model or how often they can decide. They can have an agreement on how often they want to update their model, depending on how often the data are flowing in their premises.
So usually get the feedback that the model is not performing here. We should re-update the model. How about what is the communication between the entire sites who manages the different learning versus the smaller systems who are actually using it? Is there a communication or feedback or a life cycle?
Yeah, so that's up to the federated learning platform in essence, right? So you have different organizations that they want to join the federation, so they have their own profile, so they communicate offline. Let's say, okay, we need to do that. It's not an online process. I don't think that's going to be feasible in the short term. But I don't know. Maybe Chaoyang, you have something to add here from your experience.
Yeah. So in FedML, we target this problem and decouple it as two phases. We call it detection phase and mitigation phase. So detection phase may be similar to what Dimitris has just mentioned, that we have to first understand whether there's concept drift or data drift and model drift. For example, the accuracy degrades, or maybe the data distribution is changed. So in current phase in the industry, I think there's a problem that there's no such a platform. Actually, this should be part of the platform like the MLOps, so machine learning operations, but actually there's no such a platform for you to customize for federated learning. So you see in our platform, we try to have this capability. We call it observability and monitoring capability for the model inference. So we also build a platform which we call it Urge AI. So first we have to have this Urge AI for model inference, and then we can do federation. So these are two phases we think that's a must if you want to deliver this product into reality. So the detection phase, we have multiple origins. I think the origin here is quite different. If you're talking about computer vision, large language processing, and tablet data set, for example, the XGBoost, if you train tablet data, there are different measures to detect the concept drift, especially like the data drift and model drift. There are different measures, yeah. And after you have find for example, the accuracy degrade, I think there are multiple ways to solve it. As Dimitris just mentioned, maybe people have to talk offline and to see whether can we collaborate again, because in this phase, maybe the machine is offline, you cannot train it. So people may have a coordination process to start the training. So what we hope to do is that we have a scheduler to automatically do this coordination. We have to launch the server again, so there must be a demand service there. And that demand service can launch we call it the agent. So the agent announced the training service. But the training service, most of the time, once the training is finished, it should be offline, right? But the demand service is always online. So this way, we can retrain the model and then fine-tune the accuracy by the machine learning developer, maybe multiple runs to finish the training. So So here it's not just one-time training. You have to train the hyperparameters to make sure the accuracy is similar to the previous phase or even better, right? So this phase is also very, the user experience here is also very bad in the current phase. So hopefully we can make it automated, and also maybe there are some hyperparameter optimization measures to help you train the hyperparameters automatically rather than search a long time to find it. Another way is that you can try to do active learning, means that you don't need to cache all the past data. You just pick some useful data to boost the performance to make the model recover according to the history. So that's my understanding or complete, yeah. Hopefully that answers your question.
There's also, that those are, there's far simpler ways to address some of the issues that you might see in the real world, like, like a database going down or like a system going offline, more traditional monitoring and DevOps techniques there to trigger other parts of the operation. Yeah, that helps.
Okay, why don't we go on to the final topic here, which is how is federated learning better for privacy and security? Dimitris, I think you can start that off, right?
So I think everyone would agree here that federated learning, even if you apply it, is not a panacea, meaning that you still have you still need to account for malicious actors. And this goes back to the previous question. So someone wants to perform some attacks, let's say in the federation, wants to penalize the entire federated learning process. So you could have someone that wants to destroy your federated model when you train it, or someone else that gets access to that particular model and wants to infer whether particular patients participate in a specific study. That's also called membership inference attacks. So these different concepts, it turns out that if you apply federated learning as it is in a vanilla case, then definitely you are not able to, you need to account for these different problems, right? So in that front, you can use privacy enhancement techniques like PETS technologies, or account for privacy membership. So you need to make sure that training data that you use throughout your federated learning process are not going to be able to reveal any of the participating subjects, individuals, through the model. And there are different techniques that you can use in order to make sure that your federated model, at the end of the day, when you make the final training, is robust and resilient to these particular attacks. These attacks could be, again, membership inference attacks, or could be security vulnerabilities, or even outlier detection mechanisms.
Thank you. And Karan, I think you have something to add here, right?
Yeah, absolutely. I think Dimitris did a great job of covering this. I view FL, federated learning, as just one tool in the toolbox of kind of privacy and security. What you get with federated learning is the ability to train a model without direct access to the data. And so that's great in a way for privacy, in that a modeling engineer who's building that model doesn't have direct access to potentially sensitive or regulated data. But that doesn't give you necessarily everything that you want from a privacy and security perspective. And so the kinds of attacks that Dimitris mentioned, like membership inference attacks or secret share attacks, where, for example, an attacker can extract information out of a model, like a credit card number or things like that. These kinds of attacks are not necessarily fully addressed by just vanilla federated learning. But the nice thing about federated learning is that it is a tool that's very well complemented by other techniques. So a technique, for example, called differential privacy, when combined with federated learning, gets you a nice guarantee where you can provably show that the amount of information that you're learning from one user is small. And that's something that is hard to do outside of federated learning, but in federated learning, it's quite natural. Another such tool is called secure aggregation, which enables you to cryptographically show that the individual updates sent by individual clients participating, whether that's hospitals or user devices, are not visible in plain text to any server or any modeling engineer or anything like that. And so these technologies work quite well with federated learning, but they don't come with federated learning itself. And so thinking about those tools in the toolbox and how they complement each other, I think, is important.
I think I'm off. There we are. Okay, so any questions from the audience? We got one over here again.
So do you have to do because when you sometimes describe the product perspective, there is always a question: if you don't provide some of the information, the utility of the data will not be high. So do you have to provide what is the utility of the data? I will lose the utility. The model will suffer if I don't share this information. But if I don't share it, if I don't use it, it's going to be fine. Do you have to provide that when you suggest that I have to use this data versus not? The utility versus the loss of the model or the performance of the model?
Who wants to take that one? Okay, Dimitris is stepping up.
Yeah, others will step in. But yeah, at the end of the day, you need to account when you use DP, differential privacy, private SCD, or other techniques that you provide protection against inference attacks. There are different utilities. So the trade-off is how much noise, let's say, you add during the training, and how much is the accuracy that you get based on particular noise. So you need is basically a tuning of the model, how much the trade-off of how much accuracy you want and how much privacy you want to guarantee. So there's no a gold standard, let's say, that the amount of noise that I think most of the practitioners, they do it in an ad hoc fashion, depending on the model, depending on distribution, and depending on the requirements, how much noise they need to add in order to satisfy particular levels of accuracy or other metrics or scores for the model. So I don't think there's a gold standard yet. Maybe in the future there is.
Anyone else have anything to add on that one?
Well said, Dimitri.
Okay. I think we have a question in the back there. Yeah.
Do you guys see any value in blockchain technology for security?
I think he wants to give you the mic so that people that aren't here can hear you. Yeah.
Sorry about that. Do you guys see any value in blockchain technology for security and federated learning?
Yeah, maybe I should answer this question because we are developing on-chain AI and decentralized AI based on blockchain. Yeah, we do think blockchain help federated learning at current phase because you see in federated learning, we don't have the first problem is that we don't have the proof of contribution. For example, multiple organizations like 4 hospitals contribute the model, but finally they get maybe the same reward. I think that's not fair. So in federated learning, we can in blockchain technology, we can have some general proof kinds of measure to prove how much contribution each hospital contribute to the model accuracy. So this is kind of platform we are building in FedML. And another benefit I think blockchain can help is that the smart contract, because that's a legend, you can use it as a decentralized database, which cannot be reverted, and the traceability is transparent, right? So this can be very helpful for a federated learning process to check the lazy worker and malicious users, as we discussed previously. For example, you submit an update to the blockchain, and then blockchain can stand and detect what's happened for this update. Maybe it's a malicious or lazy update. So everything is transparent to the blockchain, be recorded there. And then we can build a reputation system to see whether this hospital or this worker is useful for the federated learning, for the AI system, right? So I think the blockchain kind of like the decentralized database and the smart contract and also the general proof, actually we call it layer 2 in blockchain because you cannot do model inference or training directly on smart contract. That's very resource limited environment. So normally what we can do is offloading the model inference and training to layer 2, and then we generate some proofs for this process. But this proof generation is also very intensive, but it's okay. It's not happens on layer 1. So by this case, you can save a lot of gas costs. And simultaneously, when the proof generated, you can directly verify on layer 1. So the layer 1 verification is just constant time. So the gas cost is very small. So I think these are multiple perspectives that blockchain can help federated learning. Yeah, is it clear? Okay.
Great, and I think we might have time for last question if we put it down.
I'm just curious, because I know you mentioned that you don't have access to the data set sometimes. I just want to clarify on that. constantly being replicated out like from a hospital data, like one chunk of data set comes to you guys and that's what you work on data set, or is it like constantly replicated out to you guys as data comes in? Just curious.
Do you mean generally when working with, federated learning approaches? Well, I guess typically you want the data to stay within the walls of that organization, and that's a lot of where the value comes in for federation. And so you can approach it. You guys should opine, but you can approach accessing that data in a number of different ways depending on where that data is stored. If it's in a database, you could provide access via a user, a database user, or you could do some sort of transfer of that data out to another box within the network of that organization. I don't know if you guys have anything to add to kind of the practical aspects of getting access to those models to the data sets in these organizations.
So what's your question? Sorry, I didn't get the point.
The question was, correct me here, but if I were to repeat it, it was, what does it practically look like to get data from where it lives operationally into the models that we use to learn?
Well, you mean the data storage and the training server? How?
Is that right?
Yeah. So yeah. This actually is one of my topic during my PhD research, but I finally gave it up because that's we call it decoupling the storage and computing. So currently, if you want to decouple these two, normally we have to find some, for example, fully homomorphic encryption maybe is a measure. But at current phase, it cannot be applied to large-scale model like CNN and transformer models because the computation cost is too high there. Maybe some tablet data sets is possible. So in order to decoupling it, when I'm currently doing startup, maybe there are multiple ways, depending on the model. If the model size is small, we can try fully HE, I just mentioned homomorphic encryption. That's one way. Another way is that how we can do in-memory training. For example, you can move the data from the data storage, like the database, to a training server and build a security link. And this security link only happens in memory of this training server. So the training server does not save the data into the disk and also can guarantee the data is not transmitted to the internet. So it protects the privacy of this data, but it decouples the storage and the computing. So maybe there's a potential way there is like TEE and trusted executing environments, but that's still not ideal for large-scale model like healthcare setting. You have to do CNN and transformer for medical image. That's still for resource constrained environment for TEE. So we are still thinking whether there are potential other measures that can address this problem for large-scale models, especially for healthcare setting. Yeah, I don't have a clear answer for it. Maybe you have other suggestion. Yeah.
Yeah. So to come back to the data access, that goes back to the data access. Usually, because of the sensitivity of the data points, you have particular specific views of the data that you are more they're more protected. So you have particular samples or specific subsets of the entire database, let's say, that you can have access to. And definitely there is no data migration. The data live on the site. And what you do is you train the model over this data. So you always get access to the data on the site, but it's not definitely true that you're going to see the entire database. You're going to see a view of the data or a sketch of the data. And this is how usually you're going to work on top. And this goes back to the problem of data harmonization that, yeah, different organizations can give you different data views, but doesn't mean that the data views follow the same format or the same form. You need to apply different techniques in order to harmonize them and have them properly introduce them into the machine learning model. So that's a critical part that's not usually addressed in practicality. You perform ad hoc solutions, but to sum the answer here is that yes, you get access to data, particular sketches, and you need to perform particular techniques in order to formalize them into the format that you need in order to put them in as an input to your federated model or the deep learning model.
Karan, do you have anything you'd like to add?
No, I think everyone's answers were great.
All right. Well, I want to thank Karan, Dimitris, Chaoyang, and Jared. And thank you all for being here and listening. Thank you so much.
Thanks, y'all.